Okay, let's continue. 9.3 normal distribution. Okay, in normal distribution, normal distribution is a continuous probability distribution. So the learning outcomes, students should know how to identify the normal distribution, and then students should know how to standardize the normal random variable. Then find the probability by using normal distribution. Use the normal distribution to solve problems related to economic and business, and also use the continuity corrections in order to solve binomial problem using normal distribution approximation. Okay, normal distribution. So the normal distribution is one of the most important distribution in statistics. If a continuous random variable x has a normal distribution with mean, and standard deviation, then we write x is a normal distribution with mean and standard and variance. So this is a bell shape and the standard deviation and has mean. Okay, and then the normal probability distribution when plotted give a bell-shaped curve with the following characteristic. So the total area under the curve is 1 and the curve is symmetric about the mean, and the two tails of the curve extend indefinitely. A standard normal distribution. So the normal distribution with mean 0 and standard deviation 1 is called the standard normal distribution. Okay, so the z values or z-score are the units marked on the horizontal axis of the standard normal curve. So the continuous random variable z is used to represent the standard normal random variable z when z normal where mean equals to 0 and standard deviation equals to 1. To standardize the normal random variable x to standard normal random variable z, the following formula is used. Z equals to x minus mean divided by standard deviation where there is a symbol of mean and standard deviation. And then the standard normal table can be used to find the area under the standard normal curve probability, and the table that will be used in this topic is more than or equal standard normal table, and Bz greater than and equals to Z. So let's do this example. So if Z is a normal distribution with mean 0 and standard deviation 1, so find A, B, Z greater than 1.2. We want to find the probability of normal distribution. We need to sketch the bell shape so that we can find the area under this bell shape where it is equals to the probability of normal distribution. So in the middle we got z equals to 0. So here at your right, which is when you read the number line, you know that here we got 1, 2, 3, and before 0 we got -1, -2, -3, which is negative number. So it is equals to the number on this line. So we got positive number is here and negative number is here. That is represent the z value. For A, we have Bz greater than 1.2. Okay, so if we look at the bell shape, so we know that in the middle is 0. So at this part is positive number and at this part is negative number. Okay, so 1.2 is positive, so means that it is 1.2 here. So we can just estimate 1.2 is here. There's no equal sign, so it is dotted line. And z greater than means that this is the area of z. Okay, so we need to find this area in order to get the probability. So if we look at the table, so we can directly read from the normal distribution table. So we will get 0.1151. So this equals to 0.1151. So direct we read from the table, normal table. Okay, B, PZ less than 1.2. The question asks to find PZ less than 1.2. So when we put into the bell shape, we know that 1.2 is here, but because of there is no equal, so we just put there, noted line, and less than, so the area is equals to the probability, but in the table we cannot read from the less than, so we read greater than or more than. So we need to take, because of if we sketch all this area, it means equals to 1, and if we shaded only half, means that 0.5. So that's why when you read the table, when PZ greater than 0, so you will get 0.5. So to get Z less than 1.2, so we need to take 1 minus PZ greater than 1.2. So we will get 1 minus 0.1151 and equals to 0.8849. So it's equals to 1 minus PZ greater than 1.2. So we will get 0.8849. So this is the remarkable. So where you read when it is E greater than or greater than and equals to, so the symbol does not matter since it is normal distribution and there is a continuous random variable. The probability of normal distribution always equals to the area under the bell shape and always in positive value. C, Z less than negative 1.85. So which is equals to PZ greater than 1.85, so equals to 0.0322. C, we need to find PZ less than negative 1.85. So when we put into bell shape, so negative 1.85 is around here, and then we need to find the probability of Z less than, which is here. So the equivalent area for this area, when we change to the positive side, which is we have to take at 1.85, so this area is equals to this area. So means that is equivalent to PZ greater than 1.85. So when we read from the table, because of we cannot read from the table if Z is negative and less than, so we have to change to the positive side, so we will get directly from the table 0.0322. And D, PZ greater than and equals to negative 1.85, so equals to 1 minus probability of Z greater than 1.85. So when we read from the table, so we got 1 minus 0.0322, and so we got the last answer is 0.9678. Okay, we need to find PZ greater than equals to negative 1.85. So we put into the bell shape because we need to find the probability. There is an equal sign, so this is straight line. Negative 1.85 is here, and greater than means that the area in front of that number. So this is the area of Z greater than equals to negative 1.85. So because we cannot find any z which is negative number from the table, so we need to take 1, which is the area under the bell shape, or the area under the bell shape, minus with this area. So this area, when we convert into the positive number, which is, we need to find the equivalent area, so which is when we put 1.85, make it positive, so this area is same as this area, so means that we take 1, which is all the area, minus with pz greater than 1.85. Okay, so by reading from the table, so we got 1 minus 0.0322, which is equals to 0.9678. And then E, PZ, between 0.2 to 0.5. So we take PZ greater than 0.2 minus probability of Z greater than 0.5. So read from the table directly, so you got 0.1122. In E, we need to find PZ from 0.2 to 0.5. Okay, so by using bell shape, because we need to find the area under the bell shape from 0.2 to 0.5. We just only estimate the number which is at the positive part, and the area is around here, which is equivalent to the probability. So we take, which is equals to PZ greater than 0.2. So we take all this area minus with the area in front of 0.5. So PZ greater than 0.5. So by reading from the table, so we will get 0.4207 minus 0.3085 equals to 0.1122. And then F, P, probability of Z in the modulus greater than 2.64. So it's equals to 2 times PZ greater than 2.64. And then read from the table, so you got the answer 0.0083. Okay, F, we got P modulus Z greater than 2.64. Okay, so this is inequalities that have modulus. So we already learned before in semester 1. So when there has a modulus and greater than, means that when you open the modulus, there has two values. One is positive, 2.64, and another one is negative Z greater than 2.64. And between these two, because of it is greater than, so means that it is union. So because of it is negative Z, so we change negative number. So we got Z less than negative 2.64. So when we put into number line, we got negative 2.64 and 2.64. So we got one is positive, another one is negative, and because of this union, so both. So when we put into bell shape, it is something will be look like this. We got 2.64 here, and negative 2.64 is here, and the area that we need to find is this and here. So because of this number is equals, but the difference is only one is positive and another one is negative, means that this area is equals. That's why when we want to find this probability, so we take 2 times PZ greater than 2.64 because we need to read the table and only for Z positive. So when you read from the table, so you will get 2 times 0.00415, which is equals to 0.0083. Then the last question, property of Z in the modulus less than equals to 2 over 3. So when we open the modulus, so we got property of negative 2 over 3. Z is between negative 2 over 3 and 2 over 3. In the last example, G, we have to find P modulus Z less than and equals to 2 over 3. 2 over 3, when we change into decimal point, so we got something like 0.66666. So we have to we take until 2 decimal places, so we get 0.67. Okay, so because of this is modulus, when you open the modulus, it becomes negative 2 over 3, Z in the between, and 2 over 3. This is only for when the modulus and the sign is less than only. So you will get like this. So when you put into the bell shape, so we know that both is 2 over 3 and 2 over 3, which is 0.67. So and there's an equal sign, so negative 0.67 is here, in the middle is 0, so 0.67 is here. Okay, and this area is between these two numbers. So we need to find this area. So because we cannot find directly from the table, so we need to find by taking 1, which is the area all under the bell shape, minus with these two area, where we should know that this area is equals to this area, which is we can just write 2 times with BZ greater than and equals to 0.67. Okay, so by reading from the table, so you got 0.2514. So calculate, we will get 0.4972.